Alright, so today we're going to really dive deep into some pretty mind-blowing stuff.
I'm looking forward to hearing about it.
We're talking about AI, and specifically how AI is impacting biology.
That's fascinating. I've been curious about this intersection.
In particular, there's this powerful AI called ESM3.
I've actually heard a bit about that technology.
Let's start with the basics. Have you heard of proteins?
Yes, I'm familiar with proteins. They're those tiny, incredibly complex machines, right?
That's exactly right. They basically run our bodies.
They're essential for everything we do.
From digesting food to fighting off sickness, it all comes down to proteins. They're the fundamental building blocks of life.
And for a long time, we've been really limited in how we can study them and manipulate them. That's where ESM3 comes in.
This AI is not only able to analyze proteins in incredible detail, but it can actually design brand new proteins.
That's remarkable, especially considering it used to take nature millions of years.
That's what's so fascinating about it, the speed. We're talking about condensing millions of years of evolution into a matter of months. It's like suddenly having this power to create almost anything on a molecular level.
The implications are enormous.
The thing is, it's not just theoretical. ESM3 has actually designed a completely new protein called SMGFP that glows.
SMGFP is a variant of the green fluorescent protein, or GFP, which has been a revolutionary tool in biology for decades now. But what sets SMGFP apart is that it was entirely conceived by an AI. We're not just copying what nature has already done. We're going beyond that and creating things that don't even exist in the natural world.
That's incredibly groundbreaking. It opens up so many possibilities, particularly in medicine, like personalized medicine where treatments are tailored to your specific genetic makeup.
Instead of this one-size-fits-all approach, it's like having a custom-made solution for whatever is ailing you.
Let me give you a concrete example. Consider the MTHFR gene. Mutations in this gene can affect how people process certain vitamins that are linked to various health conditions.
That's fascinating. Imagine using ESM3 to design a therapy that specifically targets those mutations.
It would be revolutionary, especially for folks who haven't responded well to traditional treatments. And it's not just about tailoring existing therapies either. ESM3 could revolutionize drug discovery as a whole.
So instead of just treating symptoms, we're going after the root cause of the problem. Could you elaborate on that?
Well, think about it. A lot of current drugs are like using a sledgehammer to crack a nut. They might work, but they often come with all these side effects because they're not precisely targeted. But with ESM3, we have the potential to design drugs that act like precision instruments, zeroing in on the exact problem area with minimal collateral damage.
Like designing a key that fits perfectly into a specific lock. That's what's so exciting about this technology. It's not just about treating diseases more effectively, but potentially preventing them altogether. We're talking about a future where medicine is not just reactive, but proactive.
And that's just the tip of the iceberg. The applications of this technology extend far beyond healthcare. Think about material science. Imagine designing materials with properties that are unheard of today, like super strong yet incredibly lightweight materials for construction.
Or incredibly efficient solar panels that could revolutionize how we generate energy. It's like we're taking those principles of natural selection and evolution, but speeding them up exponentially, allowing us to create materials that would have taken nature millennia to evolve on its own.
And let's not forget about the environment. ESM3 could be a game changer in tackling some of the biggest challenges facing our planet. Imagine designing proteins that can break down pollutants or capture carbon dioxide from the atmosphere with unprecedented efficiency.
That would be transformative, especially as we're grappling with the effects of climate change. It's like having a microscopic army of cleanup crews working tirelessly to restore our planet.
These are just a few examples. The potential applications of this technology are vast and still largely unexplored. As ESM3 and similar AI systems continue to evolve, we can expect to see even more groundbreaking discoveries and innovations.
It's almost overwhelming to think about the possibilities. But we also have to acknowledge the potential risks and challenges with such powerful technology.
It's crucial that we proceed with caution and have these open and honest conversations about the ethical implications of AI-driven protein design. It's not enough to just focus on the potential benefits.
Like the issue of access, how do we ensure that these advancements benefit everyone and not just a select few?
We wouldn't want to see a future where only the wealthy can afford these life-changing treatments or technologies. Equitable access is paramount. We need to think about how to make these advancements affordable and accessible to all, regardless of their socio-economic status.
And what about the potential for misuse? Could someone with malicious intent use this technology to design harmful proteins or even create biological weapons?
That's a valid concern, and one that we need to take seriously. Safeguards need to be put in place to prevent this technology from falling into the wrong hands. International collaboration will be crucial in establishing ethical guidelines and regulations.
So we're talking about a multifaceted approach, not just technological advancements, but also social, ethical, and political considerations.
Precisely. We can't just blindly embrace this technology without considering the wider implications. We need to engage in a thoughtful dialogue, involve diverse perspectives, and proceed with a healthy dose of caution.
And it's not just up to scientists and policymakers. It's a conversation that we all need to be a part of. After all, the future of biology is the future of humanity. For our listeners out there, consider this. We are living in an era where the line between science fiction and reality is blurring. ESM3 has shown us that AI can unlock the secrets of biology in ways we never thought possible.
It's an incredible testament to human ingenuity, but it's also a call to action. We need to engage in these conversations, educate ourselves about the possibilities and the risks, and demand that these technologies are developed and used responsibly.
The future is not predetermined. It's being written right now, and we all have a role to play in shaping it. Let's ensure it's a future where technology serves humanity and not the other way around.
That's a perfect note to end on. This is Steve Hodges, and until next time, keep exploring, keep questioning, and keep learning.